Alrighty, so we left off here with the kidney, talking about the distal convoluted tubule in particular. Now, the proximal convoluted tubule does regulate sodium, potassium, they do regulate pH, but the distal convoluted tubule, remember we talked about how there's stuff that always needs to get done in a day, and then there's this extra stuff. The distal convoluted tubule does what you might consider the fine tuning of sodium, potassium levels, a little bit more water reabsorption, and pH control. All right. Now we're moving on to step 3. Step 1 was filtration. Step 2 was all of the tubular secretion, tubular reabsorption. Now we're talking about step 3. We haven't completely left tubular reabsorption and secretion behind, but we're talking about how the body controls ultimately blood volume and the osmolarity, the tonicity, the concentration of your plasma. Okay, so really wasn't expecting to be here right now. Let's start here. All right. We're going to start with talking about the nephron loop. You learned that the nephron loop, it's also called the Loop of Henle, and we've been forcing you to memorize that there's a descending limb and an ascending limb. And while you were learning that in 150 or 120, you're probably just thinking, who cares? Well, it turns out that the descending limb and the ascending limb of the Loop of Henle are so different, right? What's happening on the ascending limb of the Loop of Henle? On the yeah, I know I'm doing them out of order, okay? So the fluid is going to come from the proximal convoluted tubule down the descending limb of the nephron loop, up the ascending limb of the Loop of Henle, and then the distal convoluted tubule. But we're going to talk about the ascending limb of the Loop of Henle first. The ascending limb of the Loop of Henle does not allow water to leave the fluid that's inside of the tubule. Water may not leave. However, the cuboidal epithelium of the ascending limb of the Loop of Henle is very, very actively transporting sodium and potassium and chloride out of this fluid. Very active transport. Why? This very active transport of sodium and potassium out of the ascending limb of the Loop of Henle is going to make the entire renal pyramid hypertonic. Yes, it's going to be hypertonic. I know the whole body should be isotonic, but those renal pyramids, they actually get saltier and saltier and saltier and saltier as they go down towards the renal papilla. How does that happen? It is because the ascending limb of the Loop of Henle is actively transporting salts out of the loop and into the surrounding area. Okay? So ascending limb of the Loop of Henle. Now let's go back to the descending limb of the Loop of Henle. The descending limb of the Loop of Henle, it's not doing much in the way of active transport at all. It is actually just allowing water to leave the Loop of Henle by osmosis. Now, I think I've got an image in a second, but the osmolality of almost all of your body is right here at this number 300. Don't memorize it, I'm not going to ask you it, but that's isotonic for your body, 300, right? But as the fluid goes into the descending limb of the Loop of Henle, this part of the renal pyramid's got a number of 400, so water moves out by osmosis. Here, this area's got a number of 600, so water moves out by osmosis. So as the fluid is going down the descending limb of the Loop of Henle, a very large amount of water will leave that fluid. We learned that almost 2/3 of the water that started off on our journey is going to leave the nephron at the proximal convoluted tubule. Well, almost another third of the water leaves going down the distal convoluted tubule. Why? Just because of osmosis. Now, when fluid gets down here to the very bottom, the very end of the turn of the Loop of Henle, it is very, very, very hypertonic, very hypertonic. But it won't stay that way for long. Why? Because on the journey back up the ascending limb of the Loop of Henle, sodium and potassium will be actively pumped out. So by the time that fluid gets up here to the distal convoluted tubule, it is actually hypotonic. Hypotonic, right? So isotonic is 300, it went super hypertonic, and now it goes back and it's hypotonic. Now, okay, I know that when I was sitting in those chairs, I was like, this is so stupid. It just got hypertonic, now it's gotten hypotonic. What the heck's going on? Okay, two things. One thing is, yes, it's true that we went through this phase of becoming hypertonic and then we went backwards again. That really wasn't the point of the nephron loop. We'll get back to why it's a benefit, but that wasn't the point. The point was on its way down, a significant amount of water gets reabsorbed from the descending limb of the loop of Henle as it travels through the renal pyramid. That was part of the point. So yes, right now we've got hypotonic urine, but we have much less than we had when we started the loop of Henle. Okay, so yes, this urine right now is hypotonic, but there's a lot less of it than we sent in here, right? Thing two that's important about this. This system allows this ascending limb of the nephron loop to make the renal pyramid salty, and it gets saltier and saltier, more and more hypertonic as it goes through the renal pyramid. The saltiness of the renal pyramid gets used by the descending limb of the nephron loop. That's true, but it also can be used by the collecting duct. That's really important. Step three. At this moment, your urine is hypotonic. If you have consumed too much water in a day, you could make your body fluids hypotonic. The only reason that we can keep you from dying when you drink too much water is because your kidneys are capable of making a hypotonic urine. Your kidneys are not capable of making a urine that's water. We can't do that. But we can make a urine that is that hypotonic. And it's only by peeing out a hypotonic urine that you can fix a hypotonic body environment, right? So 3 good things about this. Let's head back here. The control of water loss is going to be the role of this hormone, antidiuretic hormone. Antidiuretic hormone is one of the 2 hormones that's made by the posterior pituitary, released from the posterior pituitary. When there is a lot of antidiuretic hormone, we will make a hypotonic urine. That means if I drank a super big gulp of Diet Coke, because everyone's got to have a bad habit, and that's mine, then if we drank a whole super big gulp like that on our way to campus, assuming we ever go there again, then by the time I get to campus, I'll need to use the restroom really bad. Why? Because drinking that made my body hypotonic. Antidiuretic hormone was not being made, and so since the antidiuretic hormones wasn't there, all of the stuff that I drank went straight through my kidney and into my urinary bladder and filled up my urinary bladder. If antidiuretic hormone were around, then it would do the opposite. When antidiuretic hormone is around, it's right there in its name, antidiuretic. It's against antidiuresis. Diuresis is making a large volume of urine. Okay, so it would be activated when I hadn't been drinking water at all for a while. Then it would cause me to make a very concentrated urine. Yeah, this slide is definitely out of place. We'll get back here. Okay. So it is because of the ascending limb of the loop of Henle that the concentration, the osmolarity of the renal pyramid gets more and more and more hypertonic as it goes through the renal papilla. And this osmolarity is what allows the, descending limb of the loop of Henle to let water be removed from this tubule by osmosis, and it goes here into the renal pyramid, and then it gets carried away and back to your body, right? So The ascending limb of the loop of Henle made this renal pyramid extra salty. The first place it gets used is by the descending limb of the loop of Henle. The second place it can be used is by the collecting duct. By the way, this is how the human kidney works. But your cat's kidney, it has a saltiness here of more like twice that much, like 2,400, which means your cat can create a super concentrated urine. And there is an animal in our own Sonoran Desert called the kangaroo rat that can make a urine that's so concentrated, it's almost like a paste instead of being like urine at all. Why? Because of these nephron loops. Okay, so the collecting duct. So now the collecting duct is going to travel back through the renal pyramid, right? So the urine here, it says here the tubular fluid's 300. That's not right, right? The fluid there is actually not 300, it's 100. 100. I really got to get better at that, okay? It's right at 100. So if at this moment, I was going to cover it with my hand, but you can't see that. If at this moment, the urine that is here, if at this moment that urine was allowed to just zip through the collecting duct, if at this moment the collecting duct was just acting like a plastic tube, then you would make a super watery urine and a lot of it. This is what happens when there's no ADH around. When there's no ADH around, the urine that you make is a lot of it, and it's very dilute. A lot of really watery looking pee. Now, if antidiuretic hormone is around, then there will be little tiny holes in the collecting duct called aquaporins, and those don't pump. They simply would allow water to leave the collecting duct by osmosis. And the more antidiuretic hormone there is, the more little water tunnels there are, and the more water will leave, and the more concentrated your urine will get. So if there's no antidiuretic hormone around, your urine would be super watery, and that would fix a problem when you drank too much water. If you're drinking a normal amount of water in a day and you want your urine to have a normal concentration, then there'd be a little bit of ADH around, which would open up a few of these little tunnels, which would allow a little bit of the water to return, which would make your urine have a normal osmolarity or be isotonic. But if you hadn't been drinking enough water at all, maybe been sweating because it's been really hot, then there'd be a lot of antidiuretic hormone around. There would be a lot of these tunnels opened up, and a lot of these aquaporin channels would be opened up. And if a lot of the aquaporin channels open up, then a lot of the water returns to your body, because you didn't want to lose it because you hadn't been drinking enough water. And then the urine that you make could be super concentrated. It'd be a small amount, and it would be very amber colored and very hypertonic. All right? We will come back to this at the beginning of the next lecture.